Last time we looked at that there are different types of atoms called isotopes, which have different numbers of neutrons. So here's the diagram we looked at last time, and this was showing the different isotopes of carbon. We had carbon-12, carbon-13, and carbon-14. And I mentioned last time that carbon-14 is radioactive. And that's the focus of this video. Some atoms are actually radioactive. So we'll look at what that means and how radioactive atoms can fall and break apart. So the big idea for this video is that some isotopes are unstable. So carbon-12 and carbon-13, they'll exist as a carbon atom forever unless our solar system gets exploded by our star, but that's another issue. Whereas carbon-14 atoms, the nucleus itself, it doesn't like having that many neutrons. There are 8 neutrons in carbon-14, and it's a really unstable nucleus. So what happens is, over time, there's a chance that that nucleus will eventually break apart, and it releases radiation when it does that. And radiation and radioactive atoms have lots of different uses, which we'll talk about in later videos, particularly for making energy and in medicine. But we'll get to those later on. So the next question is, what actually is radiation when it gets released? So here's some radioactive nucleus. I'm not sure what element this is, but that really doesn't matter. The main point is that it's unstable. So it's unstable. Eventually, if we wait long enough, that nucleus breaks apart and it can release two main types of radiation. We can have energy that's just released. And remember, radiation as a type of energy, that moves as a wave. It doesn't have a mass, but it moves from one place to another. And the other type is we can have a particle of radiation as well. So there are actually 3 main types, or the 3 most common types, which we'll look at now. So the 3 main types of radiation, we use the Greek alphabet to show these. There's alpha radiation, there's beta radiation, and there's gamma radiation. They're the first 3 letters of the Greek alphabet. So let's start with alpha radiation. Sometimes these types of radiation are also called decay, because decay, think about tooth decay, that means breaking down and breaking apart. So alpha decay, in alpha decay, the nucleus releases a pretty big particle. We can see it over here. It's made of 2 protons and 2 neutrons. And this particle is actually called an alpha particle. So this is one of the particle types of radiation. And actually, if we think about it, this alpha particle, this is actually just the nucleus of a helium atom. Because helium, it has the atomic number 2, so it has 2 protons, and it has a mass number of 4, which means it has 2 neutrons as well. So alpha particles are actually just a helium nucleus. So we can think of it as that original atom is splitting up into 2 different atoms. So an alpha particle is the same as a helium nucleus. It's not really a helium atom though, because there are no electrons flying around it. So let's look at an example of alpha decay. In this one, uranium is a common element that shows alpha decay, and in particular uranium-238. So there's 92 protons here, and it's an unstable nucleus. So when it breaks down, it's radioactive, it releases its alpha particle, and because it's lost 2 protons, it's actually changed to become a different element now. And it becomes thorium here. Think of it as we've gone down 2, or we've gone backwards 2 spots in the periodic table. So that element's thorium, and now we've lost 2 neutrons as well. So we've lost a mass of 4. We've gone down to 234. So this final isotope is called thorium-234. Alright, the second common type of radiation is called beta decay. And in beta decay, we're releasing a beta particle. So, surprisingly, they named the decay after the particle, just like before. And beta particles, we've actually seen them before as well. They're just an electron. But these electrons haven't come from out around the normal part of the atom. They've come from the nucleus itself. And what scientists have discovered is that a neutron is actually made up of a proton and an electron joined together. So neutrons are a proton plus an electron. And we can think of it, protons have a positive charge, electrons have a negative, so together, when we join them, they make a neutron with no charge. So in this example, we've got carbon-14, which we've come across before, and it undergoes beta decay. So if we keep waiting long enough, eventually one of those neutrons, it will spontaneously lose an electron, and now that there's no more electron, we've lost a negative charge, so it becomes positively charged. So the neutron becomes a proton. And we've lost our radiation, which is an electron flying off to go and do something else. when we look at the chemical equation for this, we started with carbon 14 and it had 6 protons, but now we know we've gained a proton, and whenever the protons change, we've made a new element. So we've now got nitrogen, which is the 7th element, but we still have the same number of protons plus neutrons, because that's the mass number. So it still weighs 14. So now we had carbon, and that became nitrogen after this decay.